In this video, we will explain how an undiagnosed failed electroviscous fan clutch often leads to repeat air conditioning compressor failure or a customer complaint of poor air conditioning performance on a Dodge truck with a Cummins diesel engine. Over the past several years, we have noticed a sharp spike in repeat compressor failure on these vehicles. As in many cases of repeat compressor failure or an ongoing customer complaint of poor air conditioning performance, the root cause of the original failure is usually not identified. These vehicles use a computer-controlled electroviscous fan clutch. Fan clutch engagement is controlled by the powertrain control module via pulse width modulated solenoid in the clutch. As pulse width increases, more viscous fluid is metered into the working area of the clutch to create a viscous coupling and therefore increase fan speed. A Hall effect sensor in the clutch reports fan speed back to the PCM. The computer considers several inputs to precisely control fan speed to match the cooling demand, including coolant temperature, oil temperature, transmission temperature, intake air temperature, ambient air temperature, vehicle speed, and the actual fan speed itself. When the air conditioning is on, the high side pressure transducer is a major input to the PCM in determining fan speed. As high side pressure increases, fan speed increases. So what goes wrong? The key thing to understand is that even a minor change in condenser airflow can have a huge impact on air conditioning performance, but under most circumstances will have little or no impact on engine temperature. A simple demonstration will illustrate this point. Here we are running a Dodge Ram 2500 with a 6.7 litre diesel engine with the AC on. It's a mild day, the temperature is only 75 degrees. Now watch what happens when we briefly block off and then unblock condenser airflow. AC head pressure increases rapidly and then decreases, but there is no change in engine temperature. This is why the root cause of compressor failure, which is insufficient condenser airflow, often goes undiagnosed on these vehicles. Because there is no evidence of engine overheating, an airflow problem is never suspected. Now look at the temperature gauge on this vehicle that came in with a failed compressor. The gauge is right in the middle of the normal range with no evidence of engine overheating. There is no obvious reason to suspect an airflow issue. Yet there is a code set for the electroviscous fan clutch. In fact, the fan clutch was simply windmilling. It was not actively drawing air through the condenser radiator. Another reason why the fan clutch is not suspected is because the malfunction indicator light is not on, even though there is a code set. This is a Class C code which does not turn on the mill. It's important to note also that in many cases a failed fan clutch does not even set a trouble code. Remember, even if it has failed, the fan will still be turning. This makes it difficult to tell with the naked eye whether it is actually engaged or not. Use the scan tool bidirectional function to command the fan on. Fan speed should increase on the scan tool and you should hear a noticeable increase in fan noise. The takeaway, of course, is that a small change in airflow can have a big impact on air conditioning performance. An undiagnosed electroviscous fan clutch is often the cause of repeat compressor failure on these trucks.